Hi students. So in this video we will just have a look at how to predict a root locus for a given transfer function. Suppose in first 1 minute of seeing the transfer function, if you can able to predict the root locus shape, then 90% of the problem is done. So unless you visualize or predict the shape of the root locus, then you end up with doing all unnecessary calculations and you will end up with no results, and you will be wasting lot of time in finding unnecessary parameters for plotting a root locus if you simply follow the procedure that is there to draw the root locus. So in this particular video we will see different possible open loop transfer functions of a system and try to write the root locus of that approximately, and then maybe you can actually find out the actual root locus. It will 100% tally with your expected or predicted root locus. So let us start with a very simple open loop transfer function GFS into HFS, which is given by the first problem, that is k by s into s plus 6. Okay, this is what I have. See, now this is the open loop transfer function. So I'm supposed to draw the root locus for values of k ranging from more than 0 to less than infinity. So this is what is the range of k. So first and foremost thing is that I have to write the S-plane representation of these poles and zeros. So now let me write the pole position, open loop pole position. One of them is at origin and the other one is at -6. So now this is my pole representation on the S-plane. Now I should be writing where does the root locus comes. Since you have only two poles, and I should know where does these two poles go, or root loci go as the value of k goes to infinity. We know that since there are no finite zeros, so both the root loci will terminate at infinity. So when it terminates at infinity, I need to have some asymptotes. The number of asymptotes is nothing but number of poles minus number of zeros. So since you have two poles and no zero, so it is number of asymptotes are 2. When you are sure that number of asymptotes are more than 1, then you have to find the centroid. Centroid is nothing but summation of all pole positions, that is real part of the pole position, which is 0 and -6. Of course you don't have any zeros there, divided by p minus z is 2. Can you see it's now -3? So I have an asymptote. I have asymptote at -3. So I have asymptote at -3. So this is my asymptote centroid, and we know the angles for two asymptotes is 90 degree and 270 degree. And we also know that if you have only two poles, the breaker point will be exactly at the midpoint of these two. So it will break here. So now the prediction is it goes this way, it goes in the opposite direction, they break here, and then it goes like this. This is the predicted root locus. It is being taken care by the asymptotes to go to infinity. Now there is no point in finding the point of intersection of root loci with the imagined axis, because it never goes to right hand side. So the system is absolutely stable, because for any values of k up till infinity, the closed loop poles never go to right hand side of the S-plane. So it will be always going like this. Can you see it's always towards the left hand side of this S-plane? So system is absolutely stable. Absolutely stable. So now this is how you can just do. So now of course I said that okay, this will always happen at the middle. You can actually find what is del of s. So what is del of s? So del of s is actually a square plus 6s plus k equal to 0. Then k can be written as minus of a square plus 6s. Then you can write its dk by ds as equal to 0. Then the derivative of this is 2s plus 6 is equal to 0. Then s is equal to -3. So that's what we saw it as. the breaker point. This is to find the BAP. This is to find the BAP. So it is so easy. So you can see we predicted this and we are trying to get it. So this is our prediction before we actually found out. We predicted because we had only 2 poles, so we predicted it's at exactly the midpoint. So this way you can able to predict before you actually solve it. Upon solving, you can just confirm that it is exactly at -3, the breaker point. And please don't write a roots array for this, and you'll end up with some unrealistic value of k, which is not because it's not at all crossing imagined axis. So it is useless to draw a root locus and to try to find k margin, because k margin is not relevant in this problem. Okay, let us see what is the next one. So next one is something like this. So let me write the second problem. It is k by s into s minus 3. So let me go back here. So this is my second transfer function, k by s into s minus 3. So looking at this, you can certainly write the roots array, predict the roots array, and then, so can you see one of them is here. So one of the pole is on at the origin. How about the other pole? Other pole is at +3. So it's at +3 there. So now we know that root locus has to exist here. It has to exist here. So this has to exist here. So once it has to exist here, so as we know that, okay, since you have now also only 2 roots onto the right side. So of course one is on the real axis. This is on the right hand side of the S-plane. Now since you have only 2 poles, the breaker point is exactly midpoint of these two, which will be plus 1.5. And if you find the centroid will also be at exactly 1.5. So what is centroid? Centroid is 0 minus of 0 plus of 3 by 2, which is exactly 1.5. So why it is, this is the real part of this pole is 0, the real part of this pole is 3, and you have P minus Z as 2. So is it not 1.5? Is the centroid at 1.5? So angles are 90 degree, 270 degree. So this is angle 90 degree, this is angle 270. No need to write the angles, because that should be mind calculation should happen. Now these poles come in this direction, this pole comes in this direction, and it breaks, and you have this here. So breakaway point is also, BAP is also at plus 1.5. You can just do the same type of calculation here. You will certainly get plus 1.5 as a breaker point. So since, if you can see here, for any values of k greater than 0, is this becoming going to right hand side, because 1 is always there in the right hand side. Now this will also be going to right hand side. System is absolutely unstable. So why absolutely unstable? Because 2 poles will be always there on the right hand side for any values of k beyond 0. That you can confirm here also, because del of s you can write it as, so what is del of s? Now it is s square minus 3s plus k equal to 0 is your del of s. So then what happens to your equation? Is it not s square s? This is your roots array. Is it not 1 k? Is it not minus 3 0? Is it not k 0? Is it not your roots array? So once this is your roots array, for any value of k greater than 0, how many sign changes? Can you see this is plus to minus 1 sign change and minus to plus second sign change. So this is having 2 poles to the right hand side, because there are 2 sign changes. So naturally system is absolutely unstable. So this is, there is no need to find, you cannot expect auxiliary equation, because auxiliary equation is not possible here for values of k greater than 0. So system is absolutely unstable. How many poles are there to the right hand side of the S-plane? Both of them are there on the right hand side of the S-plane for values of k greater than 0. And let us see the next problem. So next problem is So now it is GFS into HFS is K by S plus 2 S plus 6. Now you can see this is the transfer function. Again, number of asymptotes are 2. You can write this is my transfer function or S plane. This is 1 at minus 2, 1 at minus 6. Since we have only 2, the difference is 4 unit difference, then the breaker point as well as the asymptotes are centroid is at minus 2. So the angles are 90 to 70. You can certainly predict this is going in this direction, this is going in this direction. They break here, one will go here, other will go here. What is the system stability? I am not hearing you. What is the system stability? System is absolutely stable. For values of k between 0 and infinity, the poles are always there onto the left hand side of the S plane. System is that's it. Okay, there are no more great thing you have to do. Only thing is that you may have to prove that centroid is at minus 4. How do you prove that it's centroid is at minus 4? Is it not minus 2 minus of 6 by 2? Is it not minus 8 by 2? Is it not minus 4? So then to find this breaker point, you can find del of S, where del of S is S square plus 8S plus 12 plus K equal to 0. No need to write the roots array, because you will be unnecessarily wasting time if you find roots array, because you know that it will never cross the imagined axis. You are writing roots array to find K margin where the root locus will cross imagined axis. It's not crossing, then there is no point in finding the roots array. No need of writing roots array and finding K margin. But I can find breaker point by taking dk by ds equal to 0. So what is K now? It is minus of S square plus 8S plus 12. So make this dk by ds equal to 0. Then is it not what? 2S square plus 8 equal to 0. Then what is S square? It's equal to minus 8 by 2. Is it not minus 4? Sorry, this is not S square. This is yes. So is it not minus 4? Are you not getting breaker point as minus 4? That's it. So it is as simple as that. So system is stable. It's not simply stable, absolutely stable. Absolutely stable. Let us get the next one. I think now you can let us see what happens to this. So it's interesting. Let us see what happens. So here you have it as fourth one, GFS into HFS is equal to GFS into HFS is equal to now. So K by S plus 10 S minus 2. This is what I'm having. So for this, let us predict the positions. So this is at plus 2 and this is at minus 10, correct? So let us try to predict what is the centroid. So where is the centroid of the asymptote? Is it not minus of 10 plus of 2? And of course this is the pole positions. So one of the pole position is at plus 2, the other pole position is minus 10. Number of poles minus that is poles minus zeros is 2. Is it not minus 8 by 2, which is minus 4? Can you see the centroid is there at minus 4 somewhere here? The angle is again so and so. Now can you see the root locus exists here? Root locus go this way and then it comes this way. See, initially the roots are there on the right hand side. One of them is there on the right hand side. Afterwards it comes to left. So at some point they will meet here and then go like this. You can see they go like this. Because this minus 4 is the center point of this. Because minus 4 means it's actually 12 units. So out of 12 units you take 6 here, 6 here. Can you see minus 10 plus 6 is minus 4. Plus 2 minus 6 is minus 4. So this is the midpoint of these 2 points. So these 2 pole positions. See now, for certain values of k, the poles are, one of the pole is still here. So for a certain value of k, this pole comes onto left hand side. So now you may have to write the roots array. Why you have to write the roots array? Because the pole, closed loop pole, is crossing from right hand side to left hand side. So we can find at what value of k the closed loop pole goes from left hand side to right hand side. That is when it crosses the origin. It's not crossing the imagined axis. Since you have only one pole, it has to pass through on the real axis. So that you can find here. So what is your equation? I can write it as k into s square plus 8s minus 20 is my equation. So for this, can I write del of s as equal to s square plus 8s minus 20 plus k. Please make sure that this is the entire real part, s power 0 term. So what I'll do now is, so this del of s can be again written as, let me write it, s square plus 8s plus k minus 20. So for clarity I'll write it so. So write the roots array now. So it is a square, s power 1, can you see it is 1, k minus 20, and this is 8 and 0. So what is this s power 0? Is it not k minus 20 and 0? See now, for suppose if you take this k minus 20 equal to 0, can you see this quantity? This quantity is negative if the value of k is less than 20. So if this term is negative, if the whole term is negative, what does it mean? Plus to plus no sign change, plus to minus 1 sign change if this is negative. So when does this term is negative? When k is less than, or when it is less than 20, this will be negative. Assume that this is 19. So 19 minus 20 is minus 1. If it is 20, this will become 0. 0 means the pole is on this real axis. It is at the origin. Now this is a special case. For a value of k is equal to 20, this pole comes here. If the value of k is more than 20, so then poles are there on the left hand side. Now for these, if the pole has to remain in this position, then k value has to be less than 20. If the value of k is less than 20, you have one negative. That means one pole lie to the right hand side of the S-plane. If k is more than 20, there is no sign change. All the poles are there on the left hand side of the S-plane. So now we have predicted this and we are getting it. So you can see the prediction will never go wrong if you are properly predicting the things. Okay, let us see the next one. So what is next? Next I have, okay, this is interesting. So fifth one is k by s square into s plus 3. Let me just go there. Where is that? Okay, so this is my transformation. Again, let us predict the shape of the thing. So of course, when you are predicting the things, you should be having some minimum knowledge of how does the root locus comes and all those stuff. This is repeating poles at the origin, and you have minus 3. So 1 and minus 3. Since the poles are repeating at origin, we know that the locus will break at the same point. So at a repeating point itself is a breakaway point. So one of the breakaway point is at the origin itself. So it just breaks there itself. So shall I darken this region? Because it exists here. It won't exist here because it is even in number. How many asymptotes? Asymptotes are 3. Then I have to find the centroid. What is the centroid? Centroid is actually minus 3 by 3. Because minus 3 minus 0, it's actually minus 3 by 3 is actually minus 1. See now, this is your centroid. What are the angles? Angles are 60 degree, 180 degree and 300 degree. These are the You can see this is one angle, this is one asymptote, this is other asymptote, this is the third asymptote. So this is 60 degree, this is 180, this is 300 degree. So now this asymptote will going to go in this direction. One second. Now, okay, we know that, okay, since we have repeating poles here, it breaks there only, and we have the centroid at -1. This is -1 now. The angles of the asymptotes are 60, 180 and 300. So since we know that this has to go in this direction, that will be taken care by this 180 degree asymptote, and the two which are here will be taken care by this. So this is my prediction. To authenticate whether the prediction is correct or not, I need to find del of S. So I need to find, of course there is no need to find breaker point, because breaker point, it is known that it will happen there only. So anyhow, for clarification or for authentication, you can write that. So what is del of S? Del of S is equal to S cube plus 3S square plus K equal to 0, which you can write it as S cube plus 3S square plus 0 into S plus K. This is very important because there is no term with S, so I have to write 0, because while writing the roots array, I have to consider this polynomial. It is S cube S square, is it not 1 0 3 K, then it is S power 1 is, can you see it is now minus K. See now this is minus K, this will become what this is now, so this into this, and then this term is 0, and this will become this into this by this into this by this. Is it not K here? See now, by looking at this, can you see for whatever value of K which is positive in, for values of K greater than 0, can you see this is always negative? This is always negative. So assume that K is equal to 2. So for that, can you say this is plus 1, this is plus 3, and this is minus 2, and this is plus 2. Can you see there are two sign changes? Two sign changes, does it mean that two poles there on the right hand side, even for a very small value of K of 2? Don't take K is equal to 2. Take K is equal to 0.001. Even then, can you see this becomes negative, this becomes positive, this term positive, again two sign changes. So any values of K greater than 0 will end up with two poles on the right hand side. System is absolutely unstable. Why? Two poles always lie to the right hand side of the S-plane for values of K greater than 0. Again, how do you justify the breaker point? You can just take the one second. And of course you can able to prove that one of the breaker point is at the origin. So you can take, of course, from this you can write K is equal to minus of what? S cube plus 3S square, which you can write it as S into S square plus 3S. So from this we can clearly say that. So okay, what you can do is, okay, let me just do dk by ds for this, which will be equal to 0. Can you now see this is 3s square plus 6s. So I can take s outside. So can you see now it is 3s plus 6, so equal to 0. Can you see in this one of the root is 0, one of the root is 0, so other root is not valid one, so one of the root is 0, so breaker point is 0 is a valid point. Okay, let us see the other problems in the next video. Thank you.